So the title that we had for this originally was Regex, Feel the Fear and Do It Anyway. How many of you put your hands up if you feel like you should use regular expressions a bit more often than you do, and yet when it comes to it, you kind of run away and do something else? Anybody? Yes. And I've actually got a colleague who said, "Oh, when I told him I was doing a book and I just finished the Regex chapter on the book, he said, 'Oh, you must give me a copy of that because I need to do that.'" And he was hoping that this was going to get accepted. Little did he know he's going to see this version next week. So that's the title. A big thank you to our sponsors. None of this would happen without the sponsors. I think you've heard several times by now, if you buy anything from them, make sure you tell them you got introduced to them here. And I just must show you that again. I hope you can read that. But I love Rob's ambiguity. He says, James will be talking about Regex and not feeling fearful, or not being fearful. I'm not sure whether he means I'm not being fearful or the subject is about Regex and not being fearful. My background, I was at Microsoft when PowerShell came out. I've done a bunch of other things since. I'm currently working freelance, and hopefully in the next couple of months I'm going to actually manage to retire. I've worked on some interesting modules. So when I was at Microsoft, I did the first module that we had for Hyper-V. Doug Fink's Import Excel. A lot of the export side of Import Excel is mine. A couple of modules that are on the gallery, Get SQL and Start Parallel. And my add-ons for Microsoft Graph have kind of fallen into a little bit of a, what's the word? They're a bit neglected at the moment. So, oh, yes, well, that's the extent of the slides we have prepared. So let's actually start talking about regular expressions properly. And hopefully we'll get the right version of Visual Studio Code up. So let's make that a little bit bigger so everybody can see this. I think just to get everybody on the same page, I think we know that PowerShell has got some operators for regular expressions. So we've got the match operator, the split operator, and you notice with the split operator we have to work on banana, and we've got a replace operator. And these things work on what regular expressions terms matches. Okay, a match just describes a piece of text that's found anywhere in another piece of text. So when we say, does banana match A? Yes, we get a big true there, and let's just shorten the prompt as well. So we get a true there. Let's make that even bigger. I can go up another one, and then that's about the limit of how big I can go. So we can say, anywhere you find an A, I want you to split that text. So we split, and we'll see a bit later on, we don't have to throw away the A, but at the moment we're saying throw away the A. And I'm going to sound like I'm talking minion here, because I can change the A in banana to an E, and then I've got a banini. I don't know, do minions sound the same in all languages? I don't know. But yeah, it sounds like something. It's something in minion, and we can then start to group bits of text together. Now, here we've jumped from just using letters to suddenly using a lot of meta characters. So this was really easy, because we can go, oh yeah, I understand that. If I've never done regular expressions before, I get replace the A's with E's, and then somebody comes along and says, oh, hang on a minute, this is a read-only language down, it's a write-only language down here. What we're actually saying is these two meta characters, the up arrow and the dollar sign, mark the ends of the beginning and the end of our text. A dot can be any character. And unlike wildcards, where you basically say an asterisk is any combination of characters, in a regular expression, it's specifying repetition. So it's a dot star is any character any number of times. So what this is saying is take a sub-expression, which is any character any number of times, a space and another sub-expression, and make that the whole expression. So the whole of that string is going to be dot space, dot star will match those, then the space, and another dot star matches those. And by putting brackets around them, we can refer to that subsequently as $1 and $2. So if I do that and I say replace the first one and find the first one and the second one, swap them round, I've swapped my names round. I can do that again with two spaces in the text. And what happens there is the first dot star is what we call greedy. It goes as far as it possibly can, claims all the text, and then the next dot star says, hang on, you haven't left anything for me. And the regular expression then has to backtrack and figure out how it's going to fit the other one in. So it basically says, okay, I've claimed everything, I've claimed too much, come back. Oh, I found a space now. So here, the $1, the first expression, is James H and the space, and then the second one is my last name. We can swap that behavior around. This little difference here, this question mark, says, stop being greedy, I want you to be lazy. As soon as you've got enough to say you've got something here, stop counting. So it'll go, okay, I've got a J, that's enough. Oh, the next character's not a space. Okay, I've got J and an A. No, still not a space. It'll keep doing that until it finds a space. And now when we do that, you can see it's moved the H in with the O'Neill. Okay, so we've already got to the point where we're using these meta characters within a regular expression to do some quite interesting things that go above and beyond what we could do with wildcards. Okay, not only can we specify more interesting repetition, but we can split stuff and we can say how much we want to grab in any particular point. Now, there are a few sort of examples here. If I take a word like book and say, does it match 00? Well, we can see immediately that's got two O's in the middle. So that's going to be a successful match. If I do copy, I've said any character and any character. So I've got C, anything at all, another anything at all, and a Y, that's going to match. And then this one actually does something that we see in wildcards, and it really throws people when we see it in wildcards, that within a set of square brackets, you can have different possibilities. Now, if you ever create file names in Windows with square brackets in, and then you try and use them in PowerShell, you have to use literal path in PowerShell because it goes, oh, that's a wildcard, and the bit in the square brackets is trying to declare other possibilities for me. Okay, that's the only thing that's common between both wildcards and regular expressions, and where the syntax is identical, and it really, really throws people in wildcards. PowerShell inherited it from .NET, and it's caused more grief than benefit bringing it from .NET. But here we've said, well, I've only picked 3 of the vowels, but bug, bog, or big will match on there. So that's basically saying it's B and any one of those 3. So we get a match. And I think the next one, we've said, okay, this is now declaring a series. And when we say minus and another series, we basically say it's these, but subtract those from it. Okay, so it's A to Z without the vowels. So now we've said you can't start with a vowel. So that will match. And the last variation of what's in there, I put these two in deliberately because I want to show one of the things with the meta characters is they don't, what's the word I'm looking for? They're overloaded. They have different meanings in different places. So further up, you saw that when I used the little up arrow or the circumflex or whatever you call it in your own language, up here it was saying start of the string. Down here, inside the square brackets, it basically means not this character. Okay, so anything other than E there will match. So if I do that one, it matches. If I do not A there instead, you'll see I get a false. And here we've said BO has to be at the beginning of the text. So BO matches. OO, which we were looking at before, isn't at the beginning of the text, so it doesn't match. So that's an example of an operator that's overloaded. Dollar here is just marking the end of the string, which does throw up a question of, well, how do we test for a dollar? And inside a regular expression, the backslash character acts as an escape character. So what we're saying in this one is we don't want dollar to mean the end, we actually want it to mean the dollar sign. So here, if I test with the escaped dollar, it works. If I leave the escaped sign out, you can see it doesn't match because we have the text doesn't end after the Y. Internally, the regex operator or the regex class will provide this function escape. So if I say I want to test some input that I've got from somewhere else and I don't know whether it contains any characters it shouldn't, we can say, okay, what would that be escaped? And now I can do try dollar. And now it works again because it's escaped. So we have those things for meta characters. Once we start escaping characters, we find that there are a number of things that regular expressions use to mean classes of character. So here I have, for reasons that I don't entirely understand when I copied this, I've dived in with the most complicated one I could possibly do. But for example, if I do 1, 2, 3 ABC minus match dollar backslash D is a digit, okay, and the match operator has this magic automatic variable matches, and you can see the first match, in fact the only match we've matched the 1 in there. Now these things are case sensitive. So D is a digit, capital D is a non-digit. So now when I look at the matches, you can see that the value is actually a space. Well, that's not a terribly helpful thing to actually be able to see. I get the same with the word character. So word characters are letters and numbers. So you can see we've matched on a letter or number, And if I go to matches again, you can see it's the 1 again. If I go match on a non-word character, it's going to match on the space. And then S is a space, any kind of white space. And this time I can say not white space. And now we'll actually have something to see. And it's the 1 again. So these character classes, the common ones that we use are the 3 I've just shown you. The word character, the space, and the digit. And quite a lot of programmers get themselves into trouble because they will do a test for something like ABC match A to Z lots of times. So we're going to have lots of times in there, and we've said that's just a string of A to Z's. Now, if I come back to that, and I hope I can do that. I don't know if you can see that's an accented A, but trust me, it's an accented A. And now it says, accented A falls outside that range. You've seen my surname. I've got an apostrophe in my surname. If there's one thing that's guaranteed to annoy me, it's putting in my details on a website when they say, your name can only contain letters and spaces. Okay. People with hyphens in their name, people with accented characters in their name, we all kind of need to sort of band together. I kind of want to bring my cousin Chloe in because she's got an accent on her first name, which makes things even worse. But this really kind of grates. Now, when I say, is that a series of word characters? Word, I said, was letters and numbers, and letters and numbers includes that. And we actually have some other groups in here. There's a long old list of groups that can go in this set of braces here. And this basically says these are letters and they're lowercase letters. So I've got 2 slashes in there. So is this made up of a string of lowercase letters? And it is. And this is aware of all the characters. So if you're Scandinavian and you've got the A with the accent on it, or the O crossed through it, or any other kind of accented characters, these will match. And a lot of programmers are just lazy and they write the A to Z one. Now you've done this, don't any of you ever put brackets A to Z unless you specifically want to restrict it to those 26. Okay, use the letters one. Also in there are things for for non-Latin character sets. So here I've got a great long list, and I will try and share this after the session, but I have a long list of all the other, let's make that a bit bigger, of all the other possibles. So you can say, is it Cyrillic or is it a Greek character? So let me just try and go. Let's see if that matches is Greek. And I'll take that off the end. And I'll take that off the beginning. And if I do a quick search in here for omega, I should be able to copy that. Ooh. That's an omega with an accent. That's really pushing. I'm just going to stick to an ordinary omega, thank you very much. We'll try omega with an accent in a second, but that should come back and say I found something with a Greek character in it. And why have I got that wrong? Da, 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 da. At some point, I knew I was going to make this mistake. And
case sensitive?
It shouldn't be. Let me just try. Unknown property is Greek. No. Let's just... Oh, there you go. It is. So, yes, beware of case sensitivity inside the regular expressions. That's interesting because what I copied that from... Did I? I thought I copied and pasted it. Did I? I just typed it, didn't I? There you go. So, yes, those are all the ones. But I'm actually using that at work. There's an automated system that sends us the thing that I'm working on a bunch of files, and it happens to put Chinese characters into one of the file names. And it's the only way that we can recognize that this file is a particular kind of data to be imported is it's got Chinese characters in it. So I actually look down this list of files and go, the one that's got the Chinese characters in is the one that has to be imported over there. So we can put those kinds of collections in and say, okay, we've got these different subsets. So I think we've seen all of those. I've talked about the asterisk. The question mark, it basically says it can be present or not present. And the plus says asterisk is any number including 0, plus is any number greater than 0. So 0 is not allowed. So here I can say is Greek star. And if I take that omega out, it'll go, I've got 0 on the or more matches. Well, that's no good in most circumstances. And again, a lot of times when you write regular expressions, the debug process it worked beautifully when I had some test data. Because I went down the happy path and I tested it with the things that I thought it should work with, and then I tested it with something else, and it matched something I didn't expect it to match. And it's usually that way round. It's usually you've got extra stuff because, for example, you put a star in where really you wanted a plus. And so although star is any number including 0, a lot of the time you have to remind yourself, no, it's not any number including 0. It's at least 1 and as many more as you can find. Now, when we said lazy is basically saying as few as possible. So this is find 1, and if you find 10, use as few as you need. Don't be greedy. The question mark is basically say 0 or 1 and prefer 0 if you have a choice. And we've also got this ability to specify a number of items. Now, where was I? Yes, I wanted to show this because this is one of the places where I use regular expressions and people kind of look at me and go, are you just slightly crazy? Here I've got 2 regular expressions. They're on multiple lines, and I'm going to get to that in a second. But this really annoys me. You see how the one up here, the hashes are all beautifully lined up, and down here they're all over the place. Okay. What I can do is I can say, oh, don't tell me I've lost it. I can say, look for 28 of anything. Okay. We'll see exactly what this means a bit in a little while. But what we're saying here is look for the beginning and then exactly 28 dots, followed by any number of spaces, followed by a hash sign. And if you find those spaces, we're going to ignore the things inside these brackets. We're only going to replace the spaces, replace all those spaces. So what I can do is I can basically put in lots of extra space and then say, remove all the spaces after column 28. And I just do that, and they all come into line. Okay, and people watch me in Visual Studio Code putting in, that's a little bit involved for a regular expression, yeah? It's not, I mean, it's not horrendous, but it's quite long. And I'm using it for formatting my stuff in my script file. So let's just go back up a little way, because the brackets there were important. Now, when I said we were looking at matches earlier on, and I said we could look at banana, and I'm going to look at the bits between the first A and the last A in banana, and trap the bit in the middle in those brackets there. So now when we look at matches, match 0 is the whole thing. It's the first A, whatever's in between them, and the last A. Okay, and the bit with the brackets around it makes a second match. So that was the one that we were able to refer to when we used the $1 and $2 when I was swapping the halves of my name around. Here we've actually picked up the bit that's in the middle. Now, before, when I did banana split A, it said, well, okay, I will throw away the A's and just give you the bits between the A's. If I say I want you to treat that as a group, it then says, you're doing something special with those A's. You obviously want to keep the A's as well as the letters in between them. Okay, which is a hugely useful thing to remember, because you can say, for example, split on any punctuation mark and any number of spaces, throw the spaces away but keep the punctuation marks, as an example. One of the splits I commonly do, I get a piece of multiple line text and I just want to split it into the individual lines. This isn't going to look terribly good for the first time I run this, but I'll run it a second time. So this is saying any instance of carriage return or new line as many times as you see them. So don't worry if it's a Windows file or a Linux file. Don't worry if we've got extra lines. Just split that. Okay, and you can see it's removed the extra line. If I do that again and just pipe it to measure with one R in the conventional spelling, you can see it's split it into 5 lines. So that's a kind of useful way of doing split. Now, here we saw a couple of things with things wrapped in brackets. Who here's from the UK? Right. So there's 2 of us in the room who understand how British postcodes work. Good luck explaining this. But let's have a go, because this magic thing at the start of the regular expression says ignore white space in the expression unless I've told you with a /s you're looking for a white space character. So white spaces no longer have any syntactic meaning, and hashes begin a comment. So now we can say, okay, standard UK postcodes, I've made it too big now, but the first code is always a letter, but we exclude Q, V, or X. Okay, the second is a letter, but we exclude certain characters, and that one's optional. Okay, so you can see here we've got a group for the first 2 letters, and that identifies a town, and then we have some numbers, then we have a space. And this is really important to the post office, because that tells you basically which postman's going to deliver it. And then after the space, it's exactly where it's going to be delivered. So again, we've got 1 number and a couple of digits. Now, I did have I still got it? Or did I restart? No, I still got it. So here I've imported some data. So here is a postcode, and I happen to know, because I'm geeky like this, AB at the beginning tells me it's in the north of Scotland. AB is Aberdeen. 53 says it's some way away from Aberdeen, and then 4EA tells you exactly which street it's in. But my postcode checker here, if I make sure I've loaded that, I can then say, does that postcode match being a valid UK postcode? Haha, it does. Well, I'd have been rather disappointed if it hadn't, because I have actually checked what's in that file. And then the matches, you can see the pattern of the brackets inside there. The more 0 is the outer one, and then the more general inner one comes first. So that's basically, it's by the order of where the brackets open inside. So AB53 comes before AB, and then the whole, so that's this bit matches first, then this bit matches, and then finally we get to here and this bit matches. Okay, so that allows us to do various other bits. Now, I can go a little bit further with this. So I said AB was Aberdeen. Instead of just leaving that open bracket as I had it there, I'm just going to shrink that so that you can compare those two. All I've done is I've put question mark, angle brackets, and a name in front of here. So now if I do the same thing again, so I'll load that regular expression and say, if it matches, give me the post town. Oh, it's not R1. I changed that earlier. It's just R. At least it proves my if statement works. So the post town is Aberdeen, and I can just do matches, and you can see the ones that haven't got names have got numbers, but the one I've named has got a name. So I can now refer to it later on, and if I want to, I can do $A, $B, $C equals matches. I hope this is going to work because I haven't tested this particular one. 2, 1, 2, like that. And then A is AB and B. And so I've split that and stored it in variables quite easily. And when you're doing something as complicated as this, it does help to have these things named rather than just going, oh yeah, this bit was position 1 and this bit was position 2. So we can name them. And these things with question marks inside, here we've got a question mark X that basically says, this is special processing for this regular expression. Here we've got question mark and a name. And the one that you saw me using when I did the edit, oh, go on. This question mark and the less than sign and the equals is basically trying to point backwards. So it's saying before what you're matching on, you should find. This question mark and equals says after what you're looking at, you should find. So these are called look aheads and look behinds, and we can negate them. So if we do exclamation mark instead of equals, that says where you're not followed. So this is finding any space that isn't preceded by 28 characters and isn't followed by hash, which is basically every space in the script. So you better not replace those. But those things where you've got a question mark inside the brackets start to open up other interesting stuff. So I think that's 36 minutes of what's supposed to be 30 minutes of presenting. and 15 minutes of questions. Oh, one other thing I just wanted to show you. This is using exactly that logic. So we're saying, look backwards, and you should find the beginning of the text, and then a group of 4 characters that repeats, 4 digits that repeats. So we've got at least one lot of 4 digits, and we might have any multiple of 4 digits. And looking forwards, we've got any multiple of 4 digits followed by the end of the string. So what we've said is basically, if we've got a 16-digit number and we've got a multiple of 4 in front and a multiple of 4 behind, we should insert a space there. Now, we haven't selected anything between those two. You can see that this one's looking backwards, that one's looking forwards, and we haven't selected anything, but we just say replace that point in the text. You can think of it like the cursor flashing in the middle of your document, that it's not highlighted any characters, it's just a placeholder. So when I do that, which is supposed to look vaguely like a Visa card number, my Visa card number does begin 45, but it doesn't go on 67. It'll just insert spaces at the right place. So this becomes quite useful for formatting credit card numbers or social security numbers, or bane of my life is UK phone numbers, because people always put a digit in there that doesn't belong in there. But that's because we can't persuade people to follow the E164 notation. But there are lots of things where the question mark inside the bracket says we're going to do something special here. And that's all that's telling you. But if you find yourself writing things like that, consider going back to what I've got here and actually saying, I will explicitly write my white space, I will use white space for formatting, and I will put comments inside my regular expression. Because the big complaint is, well, it's put 2 different ways. The favourite one is you have a problem and you solve it with regular expressions, and now you've got 2 problems. There's a version for threading as well, and you have a problem and you decide to solve it with multi-threading. 3 and now problems you have. That probably doesn't work. Anyway, the problem of regular expressions being intimidating, it can be made a lot less intimidating if you comment it. So do that. Don't send that out into the world with all the spaces and comments stripped out, because you can, I mean, most of you will have had this at some point. You go back to a script that you wrote months ago and you go, what idiot wrote this? Oh, I did. And then you go look at another one that you wrote the next day and you go, I was really on form when I wrote this one, right? Be the you that puts the comments in. That's going to be my final thing on the fear of regular expressions. We have about 5 or 6 minutes for questions. Amazingly, this is completely unlike any of my other sessions. No proper slides, and I've finished roughly when I'm supposed to finish. Any questions, please fire them at me. Stunned. I will be available for other emergency replacement presenter gigs if anybody needs me. And my best wishes to Ben. Thank you all. Enjoy the rest of your conference.